Do you guys remember this formula? Circumference. R was the radius. Okay, that's not going away. So keep that in the front of your brain. Do you guys know this formula? Have you ever seen this formula before? You might have seen it in Math 1 or even middle school. Raise your hand if you've seen this formula before. Okay, put your hands down. Most of you have seen this before. All right, so we have two things now. We have the circumference of a circle, and that's 2 pi r. What's the other formula for the circumference of a circle? Boy, you just put like two formulas and mixed them all together. What's the other formula for circumference?
Area equals pi.
Oh, you're giving me the other formula, the one for area. But there's another circumference formula.
Oh yes, I see pi.
Pi d, pi times diameter, okay? And it's the pi times diameter form that's given to you on the formula sheet. But now I want you to get this in your head at the same time. The formula for the area of a circle is pi r squared, or r is still the radius. Okay? Let's remember the relationship between radius and diameter. A few of us just straight forgot the difference between radius and diameter. So it's a little bit silly, but let me not gloss over it. Somebody tell me, how are radius and diameter related to each other? India? Right, radius is always going to be half the diameter, right? If I were, name the diameter for me, using letters. Anybody? Everybody, blurt it out. KM is the diameter, segment KM. Now I'm sad I wasn't hearing the entire class responding just then. Okay, that's the diameter. The whole thing is the diameter. Well, you know what? I should have put it on this side, because that's where I wrote the word. Yes, this right here is the diameter. Okay? Name the radius for me, everybody. CM, on the other hand, is the radius. Okay? So the diameter is the whole thing. The radius is just half weight. So if for example, say if the diameter was 12, what would the radius be? 6. Say the radius was 10, what would the diameter be? 20. Okay? So if I give you one, you know the other because of the simple relationship between them. All right, that needed to be back in the front of your head. All right, too many people are not responding, so I better call on some specific people right now. Kayla. Kayla's hands in the air. All right. Kayla, the radius is 6. Well, let me save you for the more difficult one. Okay? Let me pick on somebody who didn't have their hand up. Like Paige. All right. Paige, the radius is 6. So what's the diameter? 12. Okay. Kayla, go ahead and tell me what the circumference is going to be. The circumference will be 12 pi. Okay? And again, the easiest way to think of it is pi times diameter. Diameter is 12, so pi times diameter, 12 pi. Now, the area, pi r squared. Okay? Denzel, can you guess what the area is going to be? The area is going to be 36 pi. Why? Because the radius is 6. And here it says radius squared. So that's where it's going to be 36 pi. Okay? Who did I lose? Because I might call on you next. So did I lose anybody? Is everybody ready? Okay. Kelvin. The diameter is 18. What's the radius going to be? Radius is going to be 9. Okay? Maritza. The radius is 9. Can you tell me what the circumference is going to be? It's going to be 9 pi. Wait. Not 9 pi. It's going to be, you said 18? Yeah, that was my bad. I didn't hear right. She said 18 pi, which is correct. Okay, it's just pi times the diameter, so 18 pi. Go right there. The area is going to be 81 pi. Okay, again, it's all about this r squared in the formula for area, r squared. Radius is 9, so the radius squared is 81. That's why it's going to be 81 pi. Hunter, you're really going to make me chastise you on the video? That's permanent. Kids for 5 years from now will hear me saying, Hunter, quiet please. Is that what you want? You don't want to be on the video. Okay. All right, so those are the basics of what we're dealing with. That's the foundation of what we're dealing with. Okay. Go ahead and try to do example 1. Let me give you a minute. Try to do example 1 on your own. I'm going to pause the video. All right, so we're supposed to find the area. Simply just use the formula. So the area is pi r squared, so that's going to be pi times 4.2 squared. Okay. Please, everybody listen to me on this. There were many problems on which I said you could go ahead and leave pi in your answer, and we call that exact. But on a problem where you already have decimals in the problem, we already have decimals anyway. So there's no point in leaving pi in your answer. So please, anytime you have decimals in your answer, go ahead and just give me a complete decimal answer. Don't leave pi in your answer on a problem like this. So what did you get? What's the answer? 55.2? 55.42. Okay, so I'll go ahead and round to 55.4. Any questions about that one? Okay, now this one. We're supposed to find the diameter. What are we given? Can you tell what I'm being given? We're being given the area. That's this A equals 201 square inches. We're given the area. So we're still going to use the area formula, but this 201, that's the area. I'm going to put that in the area spot in the formula. So this is going to become 201 equals pi r squared. All right? It's similar to when I used to give you the circumference and you'd have to find the radius. Okay? So I need to find I need to solve this for r, for starters. What do you think I'm going to do next? Yes. If you said divide by pi next, you are correct. We do not want to take the square root until we get r squared all by itself. Okay, so I'm going to divide both sides by pi. Don't give me a decimal yet, because if you did, you'd have to round it, and that would be not precise. For now, leave it just like this, 201 over pi, for now. Okay? How are we doing, Paige? I feel like I'm about to lose you. Okay? That leaves me with r squared equals 201 over pi. Okay? Leave it like this for a second. Now what am I going to do to get r? Blurt it out. We're going to take the square root of both sides now. Please understand that normally we would do plus or minus when we take the square root of both sides. Why am I not going to do plus or minus this time? Right, radius is a length. Can you have a negative length? No. That's the only reason why we're not doing plus or minus. So you could put this whole thing in your calculator. You know what? I turned off my calculator. So you'll have to do it for me. 7.9 or 8?
Like, or we round up to 8. Because it's 7.99 and then just...
Oh, right. 7.99. Now I understand. 7.99, so you could go ahead and round that to the nearest tenth. That's going to round to 8. Yay, am I done? Move on to the next problem? No. I found a variable, but I have to be aware of what I was being asked to find. What was I supposed to find? I'm supposed to find the diameter. Diameter. But that's easy enough. If we have the radius is 8, Jessica, if the radius is 8, what will the diameter be? Wait, the radius is 8, the diameter is? It's simpler than that, okay? Look back at this picture.
Oh, it would be 16.
Right, okay? The radius is just half of the diameter is the whole. Okay, so if the radius is 8, the diameter is going to be 16. Okay? Any questions on example 1? Intervene. Head up, eyes open, brother. Okay, sector. In the last unit, we dealt a lot with pieces of a circle, but we dealt with partial edges of the circle. That was arc length. We were dealing with arc length. Now we're dealing with area. We're dealing with the interior part of a circle. But we're dealing with pieces of a circle. So basically, when I talk about a sector, you could imagine that the circle was filled with pizza. If the circle was filled with pizza, a sector would be a slice of that pizza. So that's the best analogy I can give you, okay? So if you look at this diagram on the right, the shaded area here is going to be a sector. Do you see the difference between a sector and arc length? Arc length would just be the edge, but a sector includes all the space in the slice, okay? All right, so does this formula look sort of familiar to you? Right, it's basically the same thing. Part over whole equals part over whole. When we were dealing with arc length, what did we have on the right-hand side of the equation when we dealt with arc length? What was over here? It was angles, all right? It's the same thing, degrees. Okay, so this part didn't change. It'll be degrees over the total degrees. In other words, the angle measured divided by 360. That part's the same. But when we were dealing with arc length, when we did part over whole on the left, we were dealing with partial length and the total length. So the only difference is now we're dealing with partial area divided by the total area. Okay, that's the only difference. So remember down here at the bottom, in the last unit, this was always circumference. And we always did 2 pi r because it was always circumference, because that was the whole length. On this unit, we're dealing with the whole area. We have a new formula for that. Do you happen to remember that new formula already? You can find it.
It's pi r squared.
Pi r squared. And everybody plan on committing that to memory, okay? So the area of the circle is going to be the whole when I say part over whole. So the bottom, instead of circumference, the bottom will be total area. And instead of doing 2 pi r, we will be doing pi r squared. Okay? But it looks so familiar. So if you were good at this on the last unit, you really won't be anything new for you. Let's do an example of it. Find the area of the sector formed by angle RQS. In other words, the shaded area here. We're going to find the area of that sector. So here we go. As soon as we see that it's a slice of a circle, we're going to think part over whole equals part over whole. So let's do that. So part over whole equals part over whole. Okay, Irvin, what am I going to put on the right side of this equation? What goes in the top? Okay, what goes in the top? 63. And what goes in the bottom? 360. Okay, so part over whole, 63 over 360. Okay, Paige, what do you think I'm going to put in the top of this fraction over here? I'm going to put x, because that's going to represent the partial area. I don't know what that is yet, so I'm going to put x. Okay? Now, in the bottom here, I need the whole area, because I'm doing part over whole. I don't know it right now. Let me stay with Paige for one more question. Since I need the whole area here, how will I find it? I'm going to take the radius, which is 5, and do pi r squared. So off to the side somewhere, work your formula. Area equals pi r squared. The radius is 5. So substitute that into the formula. So the area is equal to 25 pi. And you can start to shorten your steps a little bit and go straight to 25 pi, understanding that it's 5 squared. So that's the area, okay? So I feel like I should change colors. Okay, so I'm going to take this 25 pi, and that's what I'm putting over here. Okay, and again, it's because I'm doing part over whole, and 25 pi is the whole area. Yvonne, what am I going to do now, my friend? I could multiply, but these numbers are kind of big. Is there a way I could make the numbers maybe a little smaller? Look at this fraction. What do I usually do with this fraction when I can? Help me out, anybody? Right, I usually reduce this if I can. Put this in your calculator and reduce. 7 over 40? Okay, so everybody always do that. Always reduce that fraction right away. So 7 over 40. Okay, equals x over 25 pi. All right, what now, class? India said cross multiply. Where the rest of y'all at? Okay, cross multiply. Do this, and then do this. Okay, so 40 times x, that's 40x. All right, what is 7 times 25? 175? Right, so 175. Of course, we still have that pi. Okay, what's the last step, guys? Divide by 40. Okay. Can you please give me the exact answer first? Because sometimes I will want an exact answer. Does anybody have that for me? One more time. 35 pi over 8. So this will reduce down to 35 pi over 8. Okay, so if I ask you for an exact answer, this is what I would want. Okay, now give me the decimal. 13.74. Okay, so if I ask for a decimal, I want this. Any questions? Okay, just like what we did before, so it should be pretty easy. Okay, look at example 3. A equals 22 meters squared. What do you think that is? That A equals 22. What am I giving you? Can you tell? What did you say, Hunter? I'm hearing crickets in here. Brent. A equals 22. What is that? Area. Is that the area of the circle? What is it? Let's be specific. Right. Please understand, they're putting this right here next to this little shaded part. for a reason. This A equals 22 meters squared. That's supposed to be the area of the sector only, not the whole thing. Okay, so we're given the area of the little sector. Okay, so part over whole equals part over whole. Okay, Kelvin. Let's do this part on the right-hand side first. What goes in the top? 45. What goes in the bottom? 360. Okay. Kelvin, where's this 22 going to go? It's actually going to go in the top. Okay? Because we're doing part over whole. This area is supposed to represent just the area of the shaded part. If they wanted it to be the area of the whole thing, they would probably put it inside or something like that. Okay? So we're actually going to put 22 on the top, because that's the partial area. Okay? Another way, can anyone tell me another way that I know that this area is not the area of the whole circle, other than the fact that it's sitting next to the little slice? India, how do I know? Well, meter squared, that could be either one. This could be a really, really, really big circle. Is that what you were going to say? Is there another way I can know that it's not the whole thing? Anoop?
If it was the whole circle, it would be like C.
Right.
Oh, A is the area. But would it be C?
Well, no, it would still be A. It would still be A.
I don't know.
Here's a hint. What are we being asked to find? Read the directions. What are we being asked to find?
We're being asked to find this area of the circle.
Right. It says use the diagram to find the area of circle C. We're supposed to find the area of the whole circle. Would it make sense for them to say find the area of the whole circle and then give us the area? We'd be done. So that just wouldn't make any sense. So that's another way we know that this is not the whole area, because that's what we're supposed to find. So, do not put X down here at the bottom. Put a big old A to show that that's the area of the whole circle that we are looking for. Okay? Trust me, don't use X, use A. What does this fraction reduce to, people? 1 over 8. So then I'm going to have 22 over A equals 1 over 8. If I cross multiply it, that's going to give me A equals, and I should be doing 22 times 8. 176. Okay, so the area is 176, and if I want to be really specific, I'll say meters squared, square meters. I'm not going to mark it wrong if you forget that, but it's a good habit to get into. All right, any questions about example 3? I'm losing Paige. Paige, feel free to go on to the next problem if you already understand what I am doing. Of course, if you don't understand, that means you better pay attention. Either way, you're awake, so that's good. India, talk to me. Meter squared means this. If I wanted to find the distance, from one end of the football field to the other, that's just length. So I would use meters, like a meter stick. And I would imagine putting those little meter sticks end to end, and however many it took to get across the field, that's how many meters long the field was. Okay, that's the length. Now, on the other hand, if I was trying to plant grass on that field, I need to know more than the length. I need to know how much space there is on the field. So instead of using meter sticks to find out how many meters are on the field, to get a sense of how much space there is, I would use squares. I would use a square that was 1 meter on each side. That's called a square meter. Okay? And I would be asking myself, well, how many of these will fit all over the entire football field. And that will tell me how much grass I will need to plant. That tells me how much space there is. So if you're just talking about a length, that's just a meter. If we're talking about a square shape and we want to know how many of those will fit on something, that's a square meter, and we write it as meter squared. Okay, so when you see that exponent, meter squared, it's literally, you should be picturing squares. If you just see the m by itself, you should be picturing little lines. Okay? Okay, I'm going to pause the video. Go ahead and take a few minutes and see how many of the rest of the problems you can do on your own. You've been taught everything now. You should be able to do this entire paper now. Go. Keep going. Stay focused. Just keep working. Keep working.
You're so focused, I know.
Irvine and Hunter, stop talking. Focus.
That is not one. It's a person. That's a piece of crap.
Wait, who had the draft?
Huh?
Was it draft?
Him.
Oh, yeah. Shut up.
Okay, I'm assuming everybody got the first three problems right. 4 pi, 64 pi, and 1/4 pi. Of course, you could have written this 1/4 pi as pi over 4, and that would be the same thing. But don't put decimals. Whenever it says exact, do not put decimals. Leave pi in your answer when that will be exact. Any questions on 1, 2, 3? All right, keep going. All right, check your answers. The answer number 4 should have been, the radius is 4.3. The answer number 5 should be radius of 3.4. All right, the answer number 6 should be diameter equals 11.6. All right, number 7 should be diameter equals 17.8. Okay, number 8, the answer should have been 28.3. Number 9, the answer should have been 52.4. Number 10, you should have gotten 603.2. Number 11, you should have gotten 62.9. Number 12, you should have gotten 81.3. And number 13, you should be getting 26.7. Okay? Now, Ms. Street, which one do you need to see? Number 8 was 28.3.
Okay, what's
52.4. You got it right? Okay, which one would you like me to do? 8? All right, take a look at number 8. we are going to do part over whole equals part over whole. Right there, do you know what I'm going to put here in the top? 90, because that's the partial degrees. Of course, down here I'm going to put 360. We're looking for the partial area, so I'll just put X up there for that. Nobody pack up. It's way too early to pack up. Now down here I need the whole area. How am I going to find that? Pi r squared. So off to the side, I will do area equals pi r squared. Since the radius is 6, that's going to be 36 pi. Okay? So there's my 36 pi. Okay? So I have x over 36 pi. 1 over 4. So when I cross multiply 4 times x, I get 4x. 36 pi times 1 is just 36 pi. And then I divide. So I will divide both sides by 4. So that gives me x equals. So that would be 9 pi. Okay? So that would be the exact answer.
We're supposed to find decimals or all.
Go ahead and find both for now. Okay? So that would be the exact answer, and I'm betting if I put 9 pi in my calculator, I'm going to get 28.3. Okay? Alright, we have time for one more. Tell me one that you're getting wrong or you're stuck on. 12? Okay, take a look at 12. This 39.52, is that the area of the sector or is it the total area? It's a sector. We're supposed to find the total area, so I know it's not the whole area. So when I do my part over whole equals part over whole, the 39.52 is definitely going to go in the top. That is a partial area. I'm going to put a capital A in the bottom because that's the whole area that I'm going to find. Of course, over here I'm going to put my usual 175 over 360. So I will have 39.52 over A. Hunter, what is this fraction reduced down to, brother? 35 over 72. Okay, time to cross multiply. 35 times A. That's just 35A. What's 72 times 39.52? Say it again. It's time to start packing up. 2,845.2. 0.4. Then I just divide by 35 and that's the answer.